Picture a leadership meeting where the Chief Information Security Officer leans over the table and asks a simple question. If we printed every credential our systems rely on today, how big would the stack be? Around the room, people talk about the Secrets Manager rollout, cloud key services, and the new passwordless strategy. No one mentions the keys parked in Git history, the cloud access tokens sitting in CI/CD variables, the temporary service accounts still running in production, or the credentials quietly pasted into AI prompts so a chatbot can help fix a problem. This Wednesday headline feature from Bare Metal Cyber magazine, developed by Bare Metal Cyber, is about the gap between the comforting story and the messy reality. Secrets used to mean a handful of privileged accounts and maybe a shared root password everyone wanted to retire. Today, secrets are everywhere. They live in YAML files, Terraform, SaaS connectors, low-code automations, feature flags, AI plugins, scripts, pipelines, and configuration files. Development teams trade convenience for speed. Operations teams wire infrastructure together with broad service identities. AI teams connect tools, data, and systems by handing credentials to prompts, plugins, and workflow engines. None of this is automatically reckless, but much of it is invisible to leadership until something goes wrong. Over the next few years, secret sprawl will become its own architectural risk domain. Regulations and frameworks will continue talking about identity, access management, and least privilege, but many of the hardest problems will live in the gray space, where secrets move faster than controls and live longer than the systems they were meant to support. Leaders who get ahead of this will not simply buy another vault or scanner. They will make opinionated decisions about how development, operations, and AI teams request, issue, rotate, and retire credentials. They will treat secrets exposure as a first-class metric, not as a cleanup project after the next incident. On paper, many organizations have a reassuring story. They rolled out a secrets manager, integrated it with the cloud provider, and told teams to stop hard-coding credentials. Architecture slides show neat flows from applications to vaults to key management services. In practice, many companies live in a messy middle state. Some services are wired correctly. A few flagship teams follow the pattern. Everyone else is somewhere on the roadmap. The result is a hybrid reality, one well-governed source of truth surrounded by ad hoc secrets scattered across repositories, configuration files, automation platforms, and SaaS admin panels. The vault is not the problem. The problem is that real systems rarely move in lockstep with the reference architecture. A development team racing to ship a feature drops an access token into a CI/CD variable just for now. An operations engineer debugging production adds a static credential to a script because they need visibility quickly. A vendor integration arrives with a long-lived API key that nobody has time to refactor into the standard pattern. Each decision may be rational in isolation. Together, they create a shadow inventory of secrets the vault never sees. Even when teams adopt the vault pattern, the edges leak. Wrapper scripts cache credentials in local files. Environment variables copy secrets into containers and serverless functions. Sample configuration files accidentally include real tokens because copying the working version was faster than mocking it. Over time, a single secret can appear in logs, screenshots, chat messages, test data, backups, and old configuration repositories. Leaders who only track vault adoption miss the real risk picture. The actual story is a growing population of unmanaged secrets whose lifecycle no one owns and whose blast radius no one has measured. The leadership question changes from "Did we deploy the tool?" to How many ways can one credential escape the pattern, and how would we know if it did? Until that gap is visible, secrets management remains a slideware success with operationally invisible leaks. Secret sprawl is not abstract. It comes from how people work. Developers live in short feedback loops. They need databases, queues, and third-party APIs to work in local environments, feature branches, and staging systems. That pressure creates shared environment variables, copied .env files, and golden configuration snippets passed around in chat. When a key expires and work stops, the fastest fix is often to generate a new one and paste it somewhere convenient. Operations teams create a different kind of sprawl. Their job is to keep infrastructure, SaaS platforms, and legacy systems running. To do that, they configure service accounts with broad permissions, long-lived tokens for monitoring and backup tools, and cross-tenant credentials for managed services. The risk here is often not one-off tokens. It is overpowered identities that touch many systems and rarely get revisited once they work. Do not break it becomes the dominant control. A surprising amount of risk hides inside automation scripts, orchestration tools, and global admin accounts everyone is afraid to touch. AI teams and power users add a third layer. To make AI assistants useful, people connect them to ticketing systems, knowledge bases, cloud consoles, and CI/CD platforms. That often means handing over API keys and service credentials through plugins, browser extensions, prompts, or workflow tools.
Credentials can end up embedded in prompts, stored in vector databases, or logged in debugging traces. Many AI stacks were not designed with secrets hygiene as a first-class concern, so sensitive tokens can move across boundaries traditional secrets management never anticipated.
The takeaway is that development, operations, and AI each produce their own flavor of secret sprawl. Developers optimize for speed, operations optimizes for stability, AI practitioners optimize for capability and connectivity.
A single generic policy will not fix all three. Leaders need patterns that respect how each group works, while constraining how credentials are requested, distributed, reused, and retired. Otherwise, just get it working quietly becomes, we lost control of our blast radius.
The danger is that secret sprawl stays invisible until an attacker, contractor, or unlucky internal user finds the wrong credential. One common pattern begins with a personal Git repository or an old internal project. Somewhere in the history is a database password, cloud access key, or CI/CD token that still works. An attacker who compromises that repository, or a contractor who leaves with a local copy, now has a key that was never registered in inventory and never included in rotation schedules. From the attacker's perspective, it is a golden ticket with no monitoring attached. Another failure mode lives in automation. A CI/CD pipeline variable stores a broad API token that can create infrastructure, push images, and modify secrets. The pipeline itself may be locked down, but the same token gets reused in a helper script on an engineer's laptop or in a debugging job in a less trusted environment. Compromise the weakest copy, and you bypass the strongest controls around the original. During the incident, the team discovers the token was temporary, created months ago to unblock a project, and never cleaned up or narrowed down. AI-driven sprawl introduces even subtler incidents. A well-meaning engineer pastes a live credential into a model prompt so a chatbot can run a quick API call. Someone configures an AI plugin with production access because the staging environment lacks useful data. That secret may now live in logs, conversation history, or a third-party plugin storage. If those systems are breached, the attacker does not need to break into core infrastructure. They only need to harvest the tokens lying in the AI exhaust. When that happens, leaders realize they never treated AI integrations as part of the secret surface at all. These incidents share a theme. The business believes secrets are centralized and controlled, while attackers thrive in the places where credentials are duplicated, repurposed, and forgotten. The honest assumption is that any credential can leak into the easiest path. The job of leadership is to shrink the damage when that happens.
Once you accept that secret sprawl is a product of normal work, the response has to move beyond everyone should use the vault. Leaders need to make opinionated decisions about how credentials are requested, approved, and wired into systems. Then they need to bake those decisions into the paths teams already use.
The goal is to make the safe path the easiest path. If the secure option is slower, brittle, or poorly documented, people will keep creating side doors.
One useful lens is to treat secrets like production changes. You do not rely on policy alone to stop people from pushing code straight to main. You provide pipelines, approvals, and guardrails that make bypassing controls rare and visible. Secrets need the same treatment.
For developers, that can mean standard templates that pull secrets from managed stores automatically, CI/CD patterns that never expose raw tokens to logs, and self-service flows where new credential requests automatically enforce least privilege and rotation. For operations teams, it means privileged automation accounts with sharply limited scopes, time-bounded access elevation, and clear playbooks for rotating or revoking credentials without breaking critical services.
AI integrations need their own approved patterns. Instead of allowing random plugins and browser extensions to hold production credentials, define a small number of sanctioned ways for AI systems to act on behalf of users or services. These patterns should minimize raw secret exposure and keep auditability high.
Leaders should be able to answer who granted access, what scope was granted, when it was granted, and through which integration. That may feel like friction to early adopters, but it is the only way to stop AI from becoming a blind spot where secrets leak quietly. At the leadership level, the hard truth is that not every workflow should survive. Some patterns that work today are too unsafe to keep. Platform and security teams need support when they simplify options, remove unsafe toggles, and insist on only one or two approved ways to connect systems. The organizations that succeed will not be the ones with the most tools. They will be the ones with a small, enforceable set of guardrails that match how development, operations, and AI teams actually ship work. Secrets also need to become a first-class risk domain. When they are treated as a side effect of identity or DevSecOps, they will always compete with louder priorities. Elevating secrets risk means giving it ownership, vocabulary, and regular metrics. The question is no longer, are we using a secrets manager? The question is, who is accountable for how secrets are created, used, and retired across development, operations, and AI? And how do we know whether we are getting better or worse? That starts with clear boundaries. Platform teams may own the tooling and patterns. Application teams own how services consume credentials. Security owns policy and assurance. AI teams own the additional surface they create. That division only works if it connects to metrics leaders actually review. Useful measures include discovered hard-coded secrets, the percentage of critical systems using sanctioned patterns, the age of sensitive credentials, and the number of incidents where secrets contributed to impact. These are not vanity metrics. They are how leaders argue for cleanup, simplification, and investment. Secrets should also show up in the risk register, incident reviews, AI roadmaps, and strategic planning. Major incidents should ask not only why a credential was exposed, but what pattern allowed it to be reused, overscoped, or forgotten. Board conversations about AI adoption should include questions about how credentials flow into prompts, plugins, and orchestration layers.
Regulators and customers will increasingly expect organizations to show not only that tools exist, but that leaders understand how secrets move through the environment.
At its heart, secret sprawl is about recognizing that secrets are not a side note to identity. They are the connective tissue of how the business runs. That imagined stack of printed credentials in the leadership meeting is not a scare tactic. It is a useful mental model. Every token in that pile represents a decision someone made under pressure to ship faster, unblock an integration, automate a process, or make an AI assistant useful. When you see secrets sprawl as the accumulated output of those decisions, it becomes clear that no single team or tool can solve it alone. It is a strategic risk domain that demands clear choices about how much blast radius the organization is willing to tolerate in exchange for speed. The development, operations, and AI workflows described here will not disappear. They will become more complex and more connected. The leverage comes from shaping the defaults, tightening guardrails around how credentials are issued, pruning unsafe patterns even when they are popular, and insisting that AI integrations meet the same bar as any other production change. When secrets appear in metrics, incident narratives, and AI roadmaps with the same prominence as vulnerabilities or outages, the conversation changes. It moves from, "Do we have a vault?" to, "Are we reducing the number of ways a secret can hurt us?" The most useful next moves are sharp, simple questions. Who truly owns secrets risk across development, operations, and AI? What signals show whether they are winning or falling behind? Where are temporary workarounds quietly becoming permanent infrastructure? And which one or two approved patterns are you prepared to enforce, even when they add friction? Those decisions are what keep the stack of credentials from becoming the kindling for your next major incident. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.